Ali, the recording has started. We can start.
Okay, cool. Hello everyone, welcome. I will now begin. So we'll start first with a basic recap or revision of Kubernetes, and then we'll move on to the next topic of the day. So I guess till now we have covered lots of topics. We have covered virtualization, containerization, etc. So let's start from the beginning, as this is kind of going to be a small quick revision. So traditionally we had hardware on that there was our operating system, and apps were running directly on the operating system, and all the dependencies of the app had to be on the operating system itself. It was like a local computer, or then the same thing like carried over to the cloud. Then came the concept of virtualization, where we had the hardware, the operating system, and the hypervisor, which is basically the virtual machine manager. And on top of that, we had virtual machines, and each virtual machine in turn had operating systems and had libraries or binaries, which are the dependencies of the various apps running on the virtual machine. So like this solved the problem of like virtualizing the stuff, and this is like kind of a portable image. But then again, we had this double layer of operating systems, so this kind of became a bit bulky. So then came the concept of containers, where hardware, then software. Then instead of the hypervisor, we had a container runtime, which is like a small wrapper, and it also provided access to the operating system. So the operating system was removed from the virtual machine, and instead of the virtual machine, we had a container which directly had the binaries and libraries. The operating system used was that of the original host itself, and the container runtime provide controlled access to that. And we had apps running inside containers. So this was kind of like similar to virtual machines, but then much smaller and much more portable. Okay, so now once we had containers, so we could like containerize applications. We could make them kind of like independent of the host environment and stuff. So now, like one particular app can run in a particular container, but then for a very big company or a very big organization, we just don't have one app, right? And your app does not mean like the whole system which we see. So, for example, for us, Google is a single application. Like Google search itself is a single application, but for Google, probably that's a mixture of like maybe tens or hundreds of applications. Like each individual bit is broken up into smaller components, and then that all those the working of that whole component is presented to the user as one particular app. And like that kind of makes sense, right? Because we have so many people working, and if we keep it as it was like as it is called like a monolith, where the whole of the application is kept in one bundle, then it becomes problematic to like make changes and stuff. So instead, the app is broken down into parts. Maybe even the backend is broken down into parts. The front end is broken down into parts. And all these small containers or applications are managed by teams. And then, like coming together, the whole thing is managed by some other team which is taking care of all the deployments and stuff. Okay, so moving on. Now we go to basic. I believe you all have learned a bit about Kubernetes and stuff. So consider this as a cluster, a Kubernetes cluster, which is consisting of nodes, which in turn contain pods, and pods in turn contain containers. So, like containers, we have already seen a particular, I would say, box in which an application runs. Then a pod is a set of containers. So generally speaking, a pod will only contain one container, except if there is another like very tightly coupled dependency or application inside that pod. So yeah, in all general use cases, a pod consists of a single container. Like even Kubernetes says that having multiple containers is a very advanced feature. and like that comes at a very rare and very advanced stage if you need that. And one particular node can have multiple pods. So here again, like all this cluster, node, pod, these are again like virtual things and not physical computers. So you can have like one pod per computer or multiple pods per computer or one node per computer or even a computer in the sense like a physical machine or even multiple nodes per computer. So all this is like kind of virtual, and depending on our setup we can have any kind of like division or distinguishing thing. I mean, distinguishing physical machines between them. So yeah, so like for all practical purposes in Kubernetes, we use pods as the main wrapper around containers, and we are generally concerned more with pods as the basic objects, each pod containing like one container. So yeah, basically going on, like moving ahead to another architectural diagram of Kubernetes. Just check which one it was. Yeah, going to this one. So again, as we scale up, we are scaling horizontally. We are increasing the number of containers, number of applications. So it becomes very difficult to manage all that, right? Like going to each and every. So consider for this particular example that each node is a particular computer or like virtual machine on the cloud. So now, like even if we have four nodes, it becomes very difficult to control all four of them, going to each and every one, and setting up the containers and stuff. So instead of that, what you can actually do is you set up Kubernetes, which is basically a container orchestration platform. Like that's the technical definition of that. Orchestration in the sense that it helps us to manage and like efficiently make the containers work together. So yeah, so what you just have to do is you have your container setup, and you just have to install Kubernetes on each of the virtual machines, and this is very easy with our like modern cloud providers which do have inbuilt Kubernetes support. And yeah, one more thing, like Kubernetes is not just related to Docker. You can have many other containerization platforms. But yeah, commonly Docker is used, and even like the Kubernetes architecture itself is explained in terms of Docker containers. So we'll just move forward with that. But yeah, just remember that Docker is not the only container type which you can use here. You can use any other containerization software also. Cool. So yeah. So consider like you have four nodes and you need to control all of them. So one is the Kubernetes master, which is like the main control point for all of these, not just for like for any number of nodes. And yeah, access is basically like how you control the master, and all the commands to these nodes are given through the master, which is like the main controller here, and it controls the working of all these nodes. So let's go on first to the different parts of the node. So as we've seen, pods having multiple containers, possibly multiple containers. Like each node consists of a pod, a kube proxy, and a kubelet. Now, pod we've already explained. Kube proxy is basically like a networking or communication mechanism by which it can communicate with the master and the other nodes possibly. So consider this as just like a networking interface or networking software. Kubelet is basically like let in the end just signifies that it's a small part or like uh, a small version of Kubernetes. So this is like kind of the lightweight version. I mean, this is generally, if you consider this as a master, then kubelet is the slave. Then so the master contains the controls kubelet and it's working. So yeah, like this kubelet is important for the node to be able to communicate with the master. Similarly, like all the nodes have a similar kind of architecture. Pods kubeproxy, kubelet. Then the master, it has a scheduler, which is basically used for scheduling stuff across the nodes. Controllers, which basically controls the working of all the nodes. etcd, this is like kind of, you can consider it as a not exactly a database, but kind of like all the state and the different data of all the whole deployment, or rather the whole system is stored here. The API server, now API server plays an important role here, where you can actually give commands to Kubernetes using the API server. So like there are various ways of accessing this. Generally, we use the kubectl, which is the kube command line, a Kubernetes command line, to control the whole orchestration using from the master. We also have an API server, so you can actually connect to the API server using APIs, and then you can also issue commands like via REST APIs to control the whole system. So this is like the basic overview of the architecture of Kubernetes. I'll wait for a few minutes. If anyone has any doubts, then please ping them. And if you've understood, then you can probably ping yes. Good, I see quite a few yeses here. I'm hoping the ones who haven't. Okay, yeah. The difference between etcd and persistent volume. There is a good question. So etcd is basically the data storage mechanism of the Kubernetes master, where like the data, in the sense the application data is not stored there. The data that is stored there is the like state of the whole system, like how many nodes do we have running, how many do we need, etc. Like that whole state of like the machines, the nodes, the pods, etc. Whereas persistent volume is basically like volume is basically any place where you can store the application related data. So etcd is like an internal data storage for the Kubernetes master. Volume is basically for storing the application related data, and persistent volume is like a volume which is persistent. I think we'll cover that a bit later. I mean, like technically speaking, volumes are not persistent. So once the container is destroyed, the volume itself is destroyed. I mean, sorry, the internal storage of the container itself is destroyed. So if you want to store stuff, you need to store it in a persistent space, which is provided by a persistent volume. Hope that answers your question. Okay. So now, like to manage the whole system, right? You've already seen how complex the whole system could become, and you definitely need to manage it properly so that there are no issues, like no security issues. There is proper networking between stuff, and all your containers and all are managed. So Kubernetes allows us to specify the whole config in YAML files, YAML either YML or YAML. The whole full form is yet another markup language. It's kind of similar to JSON. Like if I show you one example, you'll get to know that. Like key value pairs, left hand side is the key, right hand side is the value. Then you can have nested key value pairs. So like don't look at this like now what all text is there, but just look at, I'm just explaining the syntax. So key value, then a key, then the value is again a key value pair. So key value, then again like a nested key value pairs stuff again, and these dashes are actually lists. So you can have lists of key value pairs. So this is one of them. I can have another one here. So if I call like a group of key value pairs as a dictionary, then you can consider this spec as one particular key of a dictionary, and its value is another dictionary having the key as containers. And there is a list of dictionaries now inside, nested list of dictionaries, each having key values. So like this is the basic syntax of YAML. Definitely, it's more complex than JSON. You can have lots of other complex structures here, but we don't need to go into much detail now. Okay, so like consider, for example, if you want to set up a pod, right? So and for fine grained control and like even for versioning. So if you are writing something through the command line, then like essentially after some time that whole command is lost. You do not remember what to do and stuff. And even like for record keeping, for changing, updating, etc. So it's generally recommended to use YAML files to store your stuff. I mean to store your config. So like the basic syntax or like structure of any YAML file associated with Kubernetes is basically API version. This is basically, as I said, like each master has an API, so the API may change. So that's why we have an API version. API version currently V1. I believe we do have 1.1 or 1.2 also. Not exactly sure about that. Then you need to specify what kind of like what kind of service, I would say, service or uh, entity you want to specify here. So like for now we are specifying a pod. Now metadata is kind of like just describing it for us, like the doesn't matter that much for Kubernetes. Whatever you specify here, it's more for the humans to understand, but does play a very important role, as we'll see like in a few minutes. So now this pod is named pod 1, and it has labels of tire front end. Labels is basically again like it is actually a dictionary, and you can actually have any key value pairs, no restrictions at all here. So this is basically like for labeling stuff. So for example, if you have an app, then you can specify like your tire front end. For backend, you can specify tire backend. You can specify versions. You can specify like this is literally your space to play and how you want to specify labels. And again, like for human understanding, then spec is basically the specifications of that particular entity, which is a pod here. And you can have, as I said, as we discussed, a number of containers. So for now we need only one container, like as is common here, and the name of the container we need to specify, we want to specify as hello1. An image here is like the Docker image which we have. We've seen a Docker image formats, so this is the name of the image and this is the version of the image. So like this much part is the specification of one particular pod, and you can specify multiple pods using like these multiple dashes to differentiate, but we don't need this for now. I'll just delete it. Sorry for that. Yeah. So like this is basically normal structure and syntax. So anybody has any doubts, like you don't need to remember this, but at least like whatever needs to be specified here. Any doubts? Anyone? Cool. So looks like no doubts. So coming back to this, no. Sorry. Does this YAML file run commands automatically? No, YAML is just basically a configuration file, like how you have JSON files. Like it's quite similar to that. It's just like for storing stuff, and to run the commands, which is basically kubectl create or apply depending on what you want to do, -f and the file name. So like I don't have Kubernetes installed on my PC, which is quite difficult to do. I have not done that. We have Miniq, but I'm not going to show that. But so the syntax is kind of like this kubectl apply or create, depending on what exactly you want to do. -f is basically the file specifier, and you can do pod.yaml or whatever file you have. Yes. So YAML files is just basically a file to store the configuration. Does nothing independently. Okay, any other doubts? Cool. So we'll move ahead. So like here, this, what does that command do? So there it depends actually on what you have in your config file. Sorry, in your YAML file. So this particular command would actually create. I will not say apply for this particular thing. I will say create, like apply, create, and all depends on what exactly you're trying to achieve. But kubectl create pod.yaml. So since this particular YAML file contains the specifications or configurations of a pod, this kubectl create would actually create this pod for us. I hope that answers your question. Cool. Okay. Yeah. So Kubernetes architecture. Yeah, I don't need to explain the architecture again, but yeah. So we've seen how we need to specify the pod, right? Like how we have specified the pod. So consider the flow, like your admin tells the Kubernetes master to create a pod, and the controller and scheduler will like work together to actually create it. And etcd will actually store like this configuration. You can actually say that this configuration is stored inside etcd in like in whatever format Kubernetes does it. Definitely there are more internal defaults which are stored, but yeah, like kind of the name of the pod, the labels, the names of the containers, all that is stored in your etcd, and your pod is created on any node. So like till now we've seen how to make a pod, right? But we need to actually make multiple pods. We need to make them work together and stuff. And so again, like considering horizontal scaling, if you all remember the first lecture, we need to scale up applications. And again, this scaling up factor comes into picture because of the high number of users that we are expecting. So, like this is very common in large organizations or large applications that you have horizontal scaling. So Kubernetes actually allows you to do that. How do you scale stuff? Like again, like if you want to scale stuff, then it is the same thing that is applied again and again, right? Replicas of it are made in different nodes. Like replicas of the pods are made across the nodes, and that essentially is the whole horizontal scaling part of it. So for that, for creating replicas, Kubernetes provides you with something called as a replica set, or in short form RS. So this is actually how you specify a replica set. I'll just again go over the syntax once and then explain like what all these things are. Again, API version kind is replica set. Again, kind, the value of the kind is very important. So for previously it was pod, here it is replica set. So essentially like you would have got the idea that the value of kind is coming from a particular predefined list, predefined value, which specifies to Kubernetes what you want to create. So kind is replica set. Metadata for the replica set, we'll just name it as front end. Yeah, Neha, yeah. Pod and replica set are kind of like keywords. There are lots of other keywords also. Yeah. And yeah, for this replica set, I'll just name it as front end, and I'll apply a few labels like app, guest, book, tier, front end, whatever. And so the basic specifications of this replica set, we need 3 replicas, which means that this particular pod which we are going to specify is going to be like there are going to be 3 copies, replicas, duplicates, whatever you want to call, of that particular pod. Selector, I'll come back to selector in a minute. Now template. Template is basically how you want a pod to be made, right? So you can just compare this to a pod. So template metadata is we don't want to name this like optional name. We don't want to do that. Labels, your front end, spec, containers, some name of the container, some image of the container. So this template, inside template, it's basically the specification of the pod that we need to replicate. Now selector. So basically, like we had these labels, right? Very which we are specifying for everything. So these labels play an important role, as in how does Kubernetes know, right, that which thing we need to replicate, which thing was replicated, and which pods belong to which replication and stuff. So these labels essentially are very important, where Kubernetes keeps track of them. So selector basically means that any like this is how a particular pod is selected. Match labels tells that if these labels are matching, then that particular pod should come into the replica set. And so like for here, any pod specifying tire frontend that should be a part of this replica set. And again, like you can see, the template of the pod which we are containing does contain this tire front end label. So this, whenever this container, whenever this pod is created, it will be a part of this replica set. Uh, any questions regarding replica set? So replica set is basically just a way of specifying how many replicas of a particular pod you want, and it does offer some kind of resiliency, like in the sense if one of your pod shuts down or crashes due to any error, then Kubernetes does understand that there is an issue, and it creates another pod in its place. So we have that inbuilt. Uh, like I wouldn't say over time, but like on an average, if you see, we always have three replicas. I'm saying on an average, like in the sense if you are checking in time of an outage, then maybe for a few seconds there could be two replicas, but then like this, the number of replicas, three is like the target which it wants to achieve, and it does achieve the target. Like three is the target number, and our replica set will ensure that we always have three running. So yeah, this is basically the an overview of replica set. Does anybody have any doubts? Could you please explain match label once again? Yeah, sure. So I mean, we have labeled our pod here. I would call this the config of a pod. So we have labeled our pod with tile front end. And selector is basically like to specify which pod should be there in this replica set. So we do have multiple pods, and each of them will have the label of tile. Will have label tile front end. And for Kubernetes to understand that this pod is a part of this replica set, like selector is basically to point or specify which pod. And for that, we have matched labels. Matched labels like any particular pod whose labels are also like this dictionary, this key value pair, whichever pod whose labels are specifying this key value pair, then that pod is a part of this replica set. So if mathematically speaking, this dictionary of labels of a pod should be a superset of this match labels dictionary. Whether scaling info specified in this file, yeah, that's a good question. So here we are not exactly specifying like how to scale, how many minimum number, how many maximum number. Replica set is basically the number, like a single number. So your replica 3 is you need to have 3 pods for this. Any other doubts? Could you explain template? So yeah, template is basically like what is there in our replica set? Essentially pods. And template specifies the configuration of a pod. So as I had shown here, this template is like essentially the specification of a particular pod. Does that answer? Cool. Okay. So if this is clear with everybody, then we'll move on to the next concept. Like again, we're just building up on concepts. So I would say that these concepts should form the baseline. Yeah. So now, for example, consider like if you have a particular app, or yeah, if you have a particular app which is running in production and you want to push some upgrades to it, any kind of upgrade, security upgrade, software upgrade, feature, UI, whatever. So now essentially what would you do, right? You would like traditionally what would you do? You would stop the production of the previous version, you would set up the production of new version, and then you would shift to that, right? So at the like the time in the middle where you are shifting and you stopping, you are starting a new one, you're shifting, so that is some kind of lag, right, where the user cannot access your application. And here we do not want any such lags. Like if people are paying or if they are using that, then you want to ensure that they can always access your application. So essentially we do not want any downtime for the application. So Kubernetes helps us to do that also. So what essentially we have a couple of types of deployments. I will just explain that in a minute. I think I'll refer to the lab itself, that would be better. Okay, so just give me a minute. So I think now there were a few doubts yesterday, which quite a few of you had, and so I think Nikita will take up those doubts from yesterday and explain them. We'll move on to the concept of deployments later on. Nikita.
Yeah, hello. Am I audible?
Yeah, your voice is breaking a bit.
Okay, let me know if it's not clear. I'll start with the like all the doubts. So, like as I now related the things that we did yesterday for the example that we took in plain English and the things that we explained today. So I hope you all were able to relate them. So for the doubts, like many people had a few doubts that were not yet clear. So and due to time constraints, we couldn't clear them all. So I'll go through them one by one. The first doubt was basically first of all, I want to clear this out as like many people had doubts. If we have containers, why do we need pods, right? So I had also okay, first of all, when you deploy a container, let's say, let's forget about pods. Let's say that you are deploying a container which has two applications. Like I need two containers that are dependent on each other. So let's say I tell Kubernetes, this is my container A and the other one is my container B. So I want you to deploy them, but they are dependent on each other. Like they have few dependencies, they are tightly coupled. So we don't have the like most of the times Kubernetes deploys things like as like we know, right? If I have a pod, I need to run it somewhere on some machine, on some node, or okay. So for that node, Kubernetes decide which pod do I run in which node. Okay. So let's say if both of the nodes I have and I run them on like both of the pods, sorry, both of the containers, Kubernetes doesn't know that they are dependent on each other or they are tightly coupled. What it will do, it might like take one container and deploy it on one region, and take like one node and take another container and deploy it on another node, depending on what it's comfortable with. So in order to tell Kubernetes, no, I want you to run these things inside the same machine, but still I want them to be isolated from each other. So pods make sure that two things happen. One, even though the things are dependent on each other, they should be together running on the same machine, but I want a little isolation between them. So pods make sure that that thing happens. So is it clear to everyone that why do we need pods now? Why it doesn't, only containers wouldn't work because of the nodes part. Like Kubernetes doesn't know which node do I deploy things in. So if I have a pod, so that's why people say, that pod is the smallest deployable unit in Kubernetes, because they know that when I give Kubernetes a pod, it will deploy all of it in one single node. Like it will never happen that if a pod has, suppose, let's say, three containers, two of them will be deployed on some other node and one of them will be deployed on other node. No, that's not the case. Pod as a whole will be deployed on one single node. So does that like clear some few things, a few yes or any doubt, so that I can move ahead with the next question? So pods interconnect dependencies between containers inside node. I'll give you an example in this. So basically, let's say I have an application, and that application, like the major, so basically, like as you said, yes, they do. For an example, like ideally what happens in the cases is most of the pods have one main container which will have all the major code, like the code that I need, that container, and there will be a few something called as a helper containers. Like those helper containers, one of the container might be helping me to go through the database, the other container might be helping me to do something else. So those will be the helper containers, but my main containers need them. Like they are tightly coupled to each other. They won't, like the other one would not be able to work without the helper container. And also those containers are also called as sidecar containers, if you will read it somewhere. So inside that pod, those helper containers are called as sidecar containers. So does that clear the doubts for the pods? Dhairya, Dhwani, like any more doubts, so that I can move ahead with the next question? I mean the next concept. So using pods gives a way to couple different containers if required, but it's recommended to keep one container per pod. Ideally, yes, it is recommended to keep one container. Also, like if I have some helper containers, that's fine. They can be inside my pod. And as a whole, okay. As a whole, if I have a very big functionality, and the most, like the smallest functionality that I can take out of it should be inside that one pod. So, and like if you all must have remembered, like yesterday I gave also an example of scaling. Like if inside one pod I have two containers, but I only need to scale just one container. If you all remember the example of Kritika and Harsh I gave, that one of them is very slow and one of them is very fast to, like I can use it everywhere. So I cannot have these types of functionalities inside one pod. That will be wastage of resources. I should only have two, like when both of them are like very much dependent on each other. So Akshat, I hope like I cleared your doubt of saying like it's recommended to keep one container, but yeah, you can have helper containers as well. Okay, I will move ahead with the next point. I covered the part of sidecar. I also covered the part of single node, like complete pod should be on the single node. And we also told like Kubernetes doesn't know, like now everyone knows the importance of pods. They don't replace each other. Pods is a layer of abstraction, but it's very important also. Okay. The next doubt many people had is one of the doubt I think Abhishek had yesterday was that can we have okay, he asked me that like if I have can I have like if I have one cluster, all the nodes inside that cluster, like do they have to be in the same zone, or like is it okay if I have them in different zones? So for that, I think yes, I just want to like yesterday I told him that yeah we can, and I today also I am telling, but I'll just confirm with you that what happens is, let's say I have one cluster, and inside that cluster I need three nodes. So that's completely fine if I have like two nodes running in one zone and one other node running in another zone. But it's not possible for me to have like inside one cluster like all the nodes in different regions. So what I'm trying to say is the nodes can be in the same region and different zones, but you cannot keep the nodes in different regions, right? And that is also like not even logical to keep them in different regions. If you want your cluster to be in different like separate regions from US to Europe, you can definitely create another cluster there and send all your traffic of that cluster in that region. So Abhishek asked us that can you all show me the example of creating the nodes? Like Abhishek, you can do one thing. In GCP, there is an option of you to create a cluster at different zones. So rather, you should also try it that way. So that would be better. Because labs doesn't cover it, but yeah, you can just try in the console creating the cluster with nodes in different zones. Even for others, I hope it's clear. Also, one more thing, if I have a cluster and if I have some nodes inside that cluster, all of those nodes can communicate with each other as well. So there is no problem in communicating between like they can communicate. Now, next point is, does anybody have doubts still here, or I should move ahead with the next doubt, like the next point? But Abhishek, I hope that clears your doubt as well, that we can have them in different zones. The next part is okay. Pods part is clear. Now, the question was, ki, why do we need services if we have pods? Now, even like Ali explained about replica sets as well, right? He explained the syntax as well about like I can have more than one pods and like I can have replicas of them. So, why do we need services? I had covered it yesterday. I'm just taking a few revisions, sort of like not revisions, just clarifying a few things that were not clear yesterday. So what happens is if I have different pods, like let's say if I have pod A and the other one is pod B. Okay, pod A is like pod A needs to communicate with pod B. Let's say pod A is something which is inside, like it has the image of the front end application, and pod B runs the image of the backend application, and both of them need to communicate with each other. Okay, so if both of them need to communicate with each other, pod A needs to know the IP address of pod B. And by now, let's say taking the concept of Ali, that we can also make replicas. So let's say I make three replicas of pod B. So pod A will have to like inside its configuration files like write like pod A, like I can communicate with pod B as at these three different IP addresses, because the replicas are, I have three replicas, three of them will have different IP address. I can communicate with any of them. And let's say I have to scale down B, like I now from three I just only want one replica of pod B. So that is also a bit difficult. Like pod A will have to remove the other two IP addresses in order to make sure everything is in sync. So why does these, like why do we have to go inside these things? Why do we have to like make these pods communicate with each other, make this pod have the tension of having the IP address of whenever it scales up and scale down? So there is something called as a service. What service will do is, service will say, hey, you don't worry, what I'll do is everyone in the front end, all the pods in the front end, you all reside inside me. So if anyone will give me the IP address of front end, I will load balance or I'll redirect it to any one of you pod. So let's say if I instead of so now what pod A, like let's say if I have two different services. So if one pod of front end wants to communicate with back end, he doesn't have to worry about the IP address of any individual pod. He will simply go to the backend service. The backend service will then internally redirect it to some other pod. So that's why there is a concept of this services. Kubernetes manages it. So someone yesterday also asked, what if a service died? Okay, so first of all, let me clear service is a logical entity. It can never die. Inside a service, there are pods. Yes, they can die. Their IP address might change. But let's say if the service has some many pods, even if one of them dies, it doesn't matter to service. It will redirect it to someone else. As Kubernetes makes sure the minimum number of pods are already running. So a service can never die because the IP address of service will always be the same. The IP address will not change, right? Someone had also asked this. So I hope that clears all your this part about the services. Let me see if I like if there are any more points I have written down. Service never dies. I have explained. Um, Also, one last thing I want to take up is okay. I hope by now everyone knows about the services, pods, everything else like replica sets. Any doubts in that? They communicate with kubelet. Who? There. Till then, anyone has any doubts or are the doubts clarified? Like yesterday, there was, I guess, there was some like since it was a very plain English part, so many of the things were just high level. Today, we are going deep down in understanding about pods and services, so we are going a little bit technical. So that's sort of like covering these things then. Um, Till then, one last point I wanted to say is that all the nodes inside one okay, let's say imagine there is one big cluster. I have some nodes inside that cluster. So all of those nodes they can communicate with each other through their IP addresses. Okay, they all can do that. And then whenever there is some outside node coming to okay, whenever someone externally asks to tries to communicate with these nodes, it's not possible. So for that we will see that in the lab how all those things communication and all that happen in the networking part. So any more doubts or anything? I'm seeing the chat part. Sorry, nodes communicate with, okay, yeah. Replicas are created with the one second, I think replicas are created within the same node as the pod whose replica is created. Replicas are created within the same node as the pod whose it depends, like it depends upon where I want to that, like by default I think mostly yes, but still I can change it, like no worries, because I can change the location of the pod as well, right? By default I have to see, mostly by default they are created in the same node, but I can change. I think okay, since we have covered up these so many things, so since like we also have to cover deployment, there is a lab called as orchestrating the cloud with Kubernetes. We have covered all the concepts regarding that. Like we have covered the pods part, interacting with pod services, like labels Ali mentioned right now, and also Ali gave like the YML file. He explained it like what all those things mean. So I think there is no need for me to go through this screen. You like go through the lab, you all can do it like by your own and let us know if there are any doubts, so we can move on to the deployments part next. Ali, I am done with the
Yeah, these were the questions that Nikita answered.
Yeah, I think there's one more question here. That is, yeah, like you're taking note.
kubelet is only for health check of worker nodes. Yes, it is for health check as like it is for health check of worker nodes only. Like I don't know if it does many more. It does more things also. For the more things, even I have to see what all. But yeah, it does the health check also. If you remember the diagram that we covered yesterday, if you remember that box of the worker node, it has some K written, and I told you all it will be monitoring that part.
Yeah, so kind of like the kubelet is for communicating and interacting with the master, and so not just health check, but also the creation of pods on a node and all is also managed by kubelet. So the master will just tell kubelet to start a pod, and that the whole thing is managed by kubelet. Even like I would say health check also some part of it is done by the master. So if like the whole node fails, if the node itself is a physical computer and the whole node fails, then like having the health check just on the worker node would be a problematic, because then the health check of nothing would be performed. So some amount of that is handled by the master also.
And all the like containers inside that pod, like it makes sure that it runs them as well. Like it has that work of running containers like inside image of the Docker also.
So now we will move on to deployment.
Any more doubts before? Yeah.
Yeah. Any doubts? Then please. No doubts.
At least the doubts that you all had yesterday, I hope those are cleared as well. If not any doubts today, so all the doubts like you all had yesterday, I told you all will be covering them in detail. So I hope like we tried it to do it yet today. So next moving to deployments, yeah.
So yeah, we have seen replicas, right? So now consider deployments as replicas, but with more features in them. So replicas is essentially create these number of replicas, and once those replicas are done, like the whole purpose of the replica set is that only, like create or duplicate the pods. But deployment is actually how you manage, you scale up the whole replica, etc. So again, like specification wise, they are quite same, but like feature wise, deployment is a bigger concept than a replica. More features than replicas. So I believe, like, since I won't go into the details of the structure of a deployment config, because it's very similar to a pod. If you want, I'll just show it. Sorry, not a pod, sorry, but a replica set. If you want, I'll just show it as a comparison. Essentially the same thing. API version kind metadata, and metadata containing number of replicas, the selector, and the template of the pods to create. So now somebody was asking scaling, right? So scaling is like actually managed by our deployment. So here we have in our deployment we have replicas 3, and we can also specify how to scale it up. We can have max replicas, we can have min replicas, etc. And we can even, like, after deploying a deployment, then you can actually scale it via the command line, which is basically qct as a scale deployment name and then the number of nodes. Like a simplistic command, you will cover that in the lab. I will not go into much details of how exactly that is done. Yeah, and I believe, like, this deployment, I'll just go through the lab itself and I will explain that. Yeah, so again, the feature, the main feature of a replica set was that if a particular pod goes down, then it again starts up a new pod in place of that, and that is how it maintains the desired count or the target count of the number of replicas. Deployments, it does that also, as well as you can scale it up using the scale command, and you can also specify auto scaling. You can also specify update. So mainly here, this particular lab, managing deployments using Kubernetes engine, that is basically concerned with how you update your application. So like as I was saying before, if you have a huge application, yeah, so if you have a huge application, consider like it is running on quite a few nodes, or sorry, quite a few pods are running in that application, and you need to specify an update. So traditionally it was you stop the production environment, you like start up a new, or like in place of that, once you stop, you start up the new version of the application and then again deploy it to production. So there is some downtime associated with that, which we do not want, or essentially we want to reduce it as far as possible. Yeah, target is zero downtime. So Kubernetes actually helps you to do that. So what Kubernetes would actually do, like there are a few types of how you would deploy updates, and correspondingly a few types of how Kubernetes manages them. So before going into how we update, I would essentially like to go over the concept of service as a load balancer once more, and then I would explain that. I would go over this lab and correspondingly do that. Introduction, yeah, okay. CI/CD setup. We have a service here. We do not have a service. Give me just a minute, I'll just pull up a sample service. Just 1 second, I mean 1 minute. Yeah, sorry for the delay. I thought we had a service YAML here, but we do not have one. So yeah, essentially this is how a service is written, right? If we have in the one kind service. Nikita, had you gone over this service spec yesterday?
No, like they just know what the service is. So as you told about pods, just go through that once as well.
Okay, cool. Yeah. Okay. This again API version kind metadata, again the name of the service, and then spec. Spec is essentially the specifications of the service. And sorry, like we had in our replica set, we have a selector here, which again would be like kind of match tables. 1 second, I'll just show a better example, which would be of a load balancer. 1 minute. Finding any example of a load balancer? Yeah. Yeah, got it. Yeah. Selector, again, selector is kind of like a dictionary, sorry, match labels, where app example would be matched here. And this type is of a load balancer. So load balancer again balances between which port to connect to. And ports essentially is like how you forward the ports, which port is forwarded to which local port, and which port inside the container is forwarded to which port outside it. So think everybody okay with this specification of a pod? Any doubts? Sorry, specification of a service. Any doubts? No? Okay, cool. So again, like this service, how does this service know which pods it needs to load balance between using the selector, which is again matching labels. So essentially, for all apps named example, for all pods having the label of app example, will be the target pods which this service needs to balance the load between. Okay, so yeah, keeping this in mind, we'll now go to actually how a deployment is done and how an update is done. So essentially, if you see deployment, then here we have all this, right? We have the kind, we have the number of pods and the specification of the pod. So this deployment will actually just create the pod for you and will not do anything else. The pods are created, but then how do you connect to a pod? That is using our service, which will load balance between the pods. So essentially, here in your deployment, you are saying 3 replicas. So you would have 3 replicas of this particular pod, right? And what you need to do is you need to apply a load balancer to that. And now we know that this particular pod has app nginx in its label. So to load balance between these pods, we would have selector as app nginx, for example here. Yeah. So again, this service, example service, would load balance between all pods having app nginx as a label. So just keep this in mind, and this will be required when we are discussing deployments. Okay. So here updates are basically like kind of 3 types of updates. So one update is where you would say like you want to deploy, there is one change, for example, you have a website, you have made some UI change. I'm just taking a generic example. You have a website, you have made a UI change, and you need to update that UI change across all the users, or rather all the pods. So what you would do is you would just tell Kubernetes that this was my original Docker, container version. So here they have used, should I go into the details of replica set and deployments? Okay, fine. I'll do that. I'll explain that first and then go into this. So we saw replica set and we said that deployment has more features than a replica set. So essentially deployment uses replica sets internally. So for our normal deployments, there is one replica set containing the same number of replicas as that particular deployment. But then, like in this example, so what essentially you have 3 replicas here, right? You have 3 replicas in that particular deployment, and you need to update each one of them. So if you update them together, then what would happen is essentially you would lose out on, you would have some downtime. So instead, you just tell Kubernetes that, hey, instead of deploying version 1 of application, right here, image was nginx 1.14.2. So if you want to update this, you have a container of the new version. You just update this, you say 1.3, and you just tell Kubernetes that this is the newer deployment config which I want to deploy. So Kubernetes will recognize, right, that all this has remained the same, only the image has changed. So it will start deploying it as this is called a rolling update, which means that one by one, the replicas are changed, one by one, the pods are updated. So if all of them are updated together, you lose out, you have downtime. But if one by one they are updated, so the load balancer essentially can accommodate that, right? If one of them is failing, then it can balance between the other 2. So like one by one, it shuts down a pod, it upgrades it, then it pushes it And like simultaneously, like this is done sequentially, this is done for all the pods, and in the end you have no downtime, but you have all the pods with an updated image on them. And why I said deployments use replica sets internally. So this is done via replica sets. First we had one replica set with three replicas. Then you will have two replica sets, one with two replicas, one with one replica. So like essentially, the blue one is the original version, V1 for example, and the green one is V2. And like you move from pods from this replica set to this replica set. Like this is done by Kubernetes, not by you. You just have to specify one command, which I'm not going to the details of a command. Like it's quite simple, and you'll go through that in the lab. So does anybody have any doubts on what is the rolling update? If I want to specify in one line, then a rolling update is when your pods are updated one by one. And all the pods are updated. Cool, I think no doubts. We'll go on to Canary deployments. So I believe like some of you would have essentially heard of what is Canary or what is a Canary update. So essentially, like if we've all heard of alpha testing, we've all heard of beta testing, right? And those are like where closed communities or closed groups of people actually test out a new version of the software. But the Canary version is like the third stage where a few actual users are randomly selected and they are given the updated version. Just because like if you are not exactly sure of how would be the audience reaction, your customer reaction to the update, then that is generally what is done. Or like maybe other reasons also, but this is like one of the reasons. So essentially, like you do not upgrade all the pods, you just upgrade a few pods, and those are served to your customer. So here, instead of like having all the four pods updated, you're just updating one pod, and the rest three pods remain the same. Okay, anybody can like tell me what could be a potential problem with this? There is definitely a solution to that problem, but there is one problem if you think in a particular way. There is one problem with having one of the pods at a later version, like upgraded version, and the other having uh, previous versions. Consider this as a website, for example. The whole application is that of a website. Can anybody point out what is the problem here which we could face? You can unmute and see. Okay, so essentially the problem which we could face is, for example, there is one particular user. Consider like we have an application, we have a website, and say for example the change which we had done in the version was like previously our background was blue and now our background is green, for example. Okay, so and our deployment is Canary. So 1/4 of the deployments, like one of the pods or a few of the pods, a minority, not just a few, but a minority of the pods are having the updated version. So a minority have green color background and the others have blue color background. So what could essentially happen if we don't make this level, if we're not careful, is since there is a load balancer, and if the load balancer is just functioning in round robin or random way, as Nikhil had explained, like how load balancers function. So if they are functioning in that way, then essentially, if a particular user is refreshing the website or accessing it again, then he could be probably greeted by any random pod from your, like, connected to any random pod from here, and he would get random color. So he would be a bit confused. Like if there is one blue which is changing to green for one time, then that's okay. But then if it again which is back to blue, back to green, then that is an issue where a customer would get a bit confused. So for Canary deployments, what we essentially do is we change the algorithm. I mean, we specify the algorithm of the load balancer as being sticky for the session or the IP. Any doubts? Yeah, again, this load balancer is essentially a service, as you can see there. Any doubts with respect to Canary deployments? No? Okay, cool. And the last kind of deployment, which is blue-green deployment. So this is like kind of like a traditional deployment. So and this is generally used in cases where like there is a breaking change, right? So if our website is there is a breaking change in our website which is incompatible with the previous version of stuff, then we do not want half the users to be on the previous version, half to be on the latest version. We essentially want all the users to be on the same version. So they were on version 1, which are the blue pods, and our service or load balancer was balancing between these blue pods. Blue is meaning like in blue green deployments, blue is the original one and green is the updated one. So what essentially we would do, we would make another deployment having the latest version. We would not update the previous deployment. We would just create another deployment having the latest version. And then finally, simply just tell our service to shift from this deployment to this deployment. Shift from a deployment in the sense like the selector of the service, you will just say like the updated labels. So if this deployment has version 1.0.0 and this is version 2.0.0 and the service was actually pointing to version 1.0.0, we would just change this to version 2.0.0. So for the time being, we previously, if we want like 3 replicas, then we had 3 replicas of the original version. Our service was pointing to that. We create a new deployment having 3 replicas of the latest version. So at one particular point of time, we would have 6 replicas, and then we would shift the service to the new deployment and delete the original one. So the disadvantage here is that at one particular point of time, you need more or like rather 2x number of replicas than is the target. Just so that you can like if this is already set up, you can switch to this quickly. So this was basically the concept of blue-green deployments, and this lab is basically first you create a deployment and then you apply all these updates to that deployment. Any doubts? Any questions like regarding the whole session? Yeah. So which is the best among the three? Best among the three is like there is no specific specific like this is the best or something like that. It generally depends on what is the exact use case, what is the exact change or update you want to specify. I would say target like rolling updates, and the next question also together. Like, can you please explain rolling up? No, sorry. Is blue-green deployment ever preferred? Yeah. So blue-green deployment, rolling, and Canary they have like a particular preferred use case. So rolling updates are generally like a normal updates, non-breaking updates. Non-breaking in the sense like if you have what I call like non-breaking is for those who are familiar with versioning and stuff. So non-breaking changes are like minor changes, and breaking changes are major ones. So there is an incompatibility which occurs between breaking changes. So rolling updates are generally for minor ones where it doesn't matter like if half your users are on new versions, half are on previous versions. That is where a rolling update is done, and like it can be done simply. Takes a bit of time, but yeah, it can be done simply, quickly, easily. Canary deployments are basically, I would say, they would be used for customer testing or customer feedback and stuff. Like, or rather, if you have, I don't know, maybe some other restrictions like you want to roll it out in a particular country and not globally, or you are trying it country wise. Like for example, Twitter and all do have updates rolled out country wise, right? We had the Twitter, what is that called, stories or something that feature coming up in Brazil and US before India. So that is one of the things of Canary updates, like to a specified user base. Blue-green is essentially when you have a breaking change and you want all the users to be on the same version at all times. Can you please explain rolling updates again? Yeah. So rolling updates is basically you have a set of pods, you want to update all the pods, but you if you like update them together, then there will be a downtime. So what you do, you just take one pod, upgrade each one of them. Is Chrome Canary based on the same idea as Canary deployment? I'm not exactly aware about Chrome Canary, but yeah, if it is targeting only specific number of users, then yeah, that is called a Canary deployment. Uh, okay, 1 second. Dhwani Atharva, I hope I answered your doubt. Akshat, sorry, I missed your doubt. Users are directed to old new pods randomly in Canary deployment? No. Users are not directed randomly. That's what I was saying. That the load balancer should have a particular session affinity. If you see in this particular lab also, they have specified this idea of session affinity. The load balancer has special session affinity of client's IP or something like that. So it's one particular client will not be redirected to random different chains. Is blue-green deployment ever preferred? I covered this. Can you please explain loading updates again? Okay, done. Is from Canary done? Do Google Cloud charge for these extra machines and VMs in blue-green deployment? Yes, Rakesh. Yes, Rakesh. You are charged for everything that you use. So when rolling if two pods are tightly connected and not updated together, there will be a problem with working of application. No, so pods are not cannot like pods are replicas. They're just replicas of each other. Uh, it's essentially containers inside pods which could be tightly coupled. Pods are just replicas of each other. Like the pods which you're referring to here are replicas. So there is no like connection in between them. If there is a connection, then that has to be like within a pod between two containers. Rakesh, Vishal, cool, okay. Rakesh says, but then there are only a few minutes, right? Yeah, Rakesh, there are only a few minutes, but then consider like, for example, a banking company or a stock trading company. Like even seconds matter for them. So having downtime of minutes or even a few seconds could be have a negative impact and negative review from their customers. Hopefully answered your doubt. Any other doubts, anyone? I think like we have covered 3 labs today. Orchestration, which was generally our generic deployments and stuff. Managing deployments using Kubernetes engine, which was our updating stuff. And here in this particular, okay. Yeah, this particular lab deployment manager full production is essentially a combination of all the things which we have run until now. So we have load balancing, you have monitoring, you have dashboards, you have deployments. This was in relation to this stuff. Let me see do Google Cloud charge for these extra machines and VMs? Acha, okay, you were asking that what Google Cloud charge for this even if there is a few minutes? Yeah, so generally your compute environments, your virtual machines are charged by the hour, like in the sense in terms of time. So yeah, if you do create the extra resources, then you are charged. I mean, if somebody wants to not be charged that much, then there could be complex situations where they could possibly like decrease the memory resources or like the resources accessed by a container, then I don't know, like decrease the resources used by a container, increase and like then deploy, then employ your blue-green deployment, then again upscale it. But yeah, you could do that. But yeah, if you are making new resources, then you could be charged. I mean, you would be charged for that. Any other doubts? Otherwise, like we are done with today's session. I think no doubts. Would you like to end?
I'll just share what we did today, and then we can. Hello. So in this doc that I mentioned, uh, today is day 7, and all the labs that Nikita and Ali mentioned, you can find it here. It orchestrating the cloud with Kubernetes. Then the 2 labs that Ali mentioned, deployment manager full production and managing deployments using Kubernetes engine. Ali, am I correct with this?
Yeah, yeah.
Okay. So you can find this that it is in skill batch 6, lab 3, lab 4 and lab 5. All of these are continuous labs. So now that we have gained an understanding, we can do these labs. All of them are in skill batch 6. So this was our day 7 session. I hope all of you have this doc link. If not, let us know. Thank you everyone for attending. Thank you Ali and Nikita for this session as well.